All right. We've already learned one method for solving quadratics, which was the square root method, and that works really well when there's only an x squared term. However, that's not always going to be the case. So on some of the tougher ones, we'll need to solve by factoring. Now, solving by factoring abuses what's called the zero factor property of zero. So if something equals zero and it's a product, that means that somewhere along the line, one of the factors has to be zero. If you're multiplying a bunch of stuff, it won't equal zero unless one of the factors is zero. So zero times something or something times zero, or even if you have a bunch of factors, one of them along the line has to be zero. So what we're going to do is we're going to try to set everything equal to zero. And then instead of it being an addition problem or a subtraction problem, we're going to cheat and turn it into a multiplication problem. And that's going to allow us to cheat and use this zero factor property. So here's our first example here. I'm going to move over the 9x by subtracting. Again, what that does for us is now it equals zero to get us ready to use this property. Then the next thing we have to do is factor it out. Now, today we're worried about factoring binomials. Hopefully this should be the easier part here. So there's two ways to do that. One way is with the greatest common factor, and the other is with a difference of squares. So what I'm going to do here is I'm going to look for my greatest common factor. What can I divide evenly out of this? Well, I can divide a 3. So that's going to be part of my greatest common factor. I can also divide an x evenly out of both of these. So I'm going to divide out 3x. So 3 divided by 3 is 1. X squared divided by x is x. You'll know you've done it right if 3x times x is 3x squared. Negative 9 divided by 3 is negative 3. X divided by x is 1. So now this is a multiplication problem that equals 0. So this will only be true if this factor is 0 or this factor is 0. Now, a lot of you will get to the point where you can do this in your head, but for now, let's just go ahead and say 3x equals 0. Okay, when will this equal 0? Well, divide by 3, x equals 0. Same thing here, x minus 3 equals 0. Add 3. So these wind up being our two solutions. We can check those real fast. If we plug in 0, we get 3 times 0, 0 minus 3. So 3 times 0 times negative 3 is 0. Same thing, we can do the 3. 3 times 3 times 3 minus 3. That's 3 times 3 times 0, which is 0. So both of those wind up being valid solutions. Okay? Let's look at this example right here. This is already set equal to 0. Hooray! But there's no greatest common factor here. Okay, now we could solve this using the square root method. Nothing wrong with that. Use that if you want. But we're going to try factoring using a pattern called difference of squares. Now, difference of squares is one of those things in math where the name says what it is. Difference means subtraction. Squares is referring to perfect squares. So we're looking for a difference of perfect squares. Now, here's why this pattern works. So if you have a difference of two perfect squares, it can be factored out where it's the square root of both of these. So it's a plus that and a minus that. Okay. Now the reason this works is if you do all of this multiplication here, you wind up with a squared minus ab plus ab minus b squared. Well, what happens to those middle terms? They go away. So anytime you see this pattern right here, this perfect square minus another perfect square, a difference of squares, you can factor it out in this form. So here's an example. X squared is a perfect square. It's x times itself. 9 is 3 times itself. So what's the square root of x squared? It's x. Square root of 9 is 3. So the pattern is x plus 3, x minus 3 equals 0. And again, we can set both of these factors equal to 0. And when we solve, we get x equals negative 3 and x equals positive 3. Both of those wind up being solutions to this. One more for good measure. This one is not equal to 0. So if we want to use, if we want to solve by factoring, we're going to have to do that. We're going to have to move this over by subtracting it. So there's no greatest common factor. We can't use that. So we're going to look for a difference of squares. Is it a difference? Yes, it's subtraction. Is it a perfect square? 4 is a perfect square, 2 times 2. X squared is a perfect square, x times x. 25 is a perfect square, 5 times 5. So we use this pattern up here. The square root here is 2x. The other square root is 5. 2x plus 5, 2x minus 5. A little bit off the screen there, apologize. And then we can set these equal to 0. 2x plus 5 equals 0. 2x minus 5 equals 0. Again, some of you will learn to do this in your head. So x equals negative 5 halves, and x equals positive 5 halves. All right, so that is solving binomials by factoring.